So in question number 8, they're asking us to consider what would happen if we take the slope of a line that predicts SAT scores based on family income. So here we have SAT scores from family incomes, and the slope is 6.25 points per $1,000. But they're also giving us this correlation coefficient of 0.48. And then it says that slope, we want to know what the new slope would be if we ended up taking family income and scores and swapping them. So let's kind of take a look at this. What they gave us, so I'm going to put what they gave us, is they gave us that our x variable is going to be money in $1,000, and the y variable is the points that's happening. So what happened was they went through, they did this entire regression process, and they ended up with a slope. Now, as a reminder, your slope is B1. So when they did this, what happened was they got that the slope was 6.25 points per $1,000, and that all equals this r times sy over sx. So r times sy over sx. And you might go, well, why did I not put r? The reason I didn't put r is because they told us what r was right here. So r was 0.48. Well, if I take this and I divide both sides by 0.48, what would happen is I would end up with a brand new number that would leave me with just sy over sx. So that's what I'm going to do. I'm going to take this and I'm going to say divide this side by 0.48. But if I say that means I need to make some room over on the left-hand side to also do the same thing, to divide by 0.48. So when I do this, I'm going to give myself a little bit more room here. I'm going to say 6.25 divided by 1,000. I'm going to hit equal, and now I'm going to divide that number by 0.48. And when I do this, what I get is 0.0130, and then I get a bunch of other little numbers, is equal to this sy over sx. Now, what this is telling me is, excuse me, if I take this slope that I just got here and this sy and sx, I can swap the y variable and the x variable. And one of the nice things about that is because this s stands for the standard deviation of the y variable and the standard deviation of the x variable. When I swap them, the standard deviations aren't going to change just because I decided to change the x-axis to be the y-axis and the y-axis to be the x-axis. So these are still going to be the same. But what I need to do is I need to make sure that I turn this into a fraction so that when I take these and swap them, I can do the same thing over here. So the new version of this would look something like 1 over 0.0130, and then all of those decimal numbers that I got on the calculator earlier. And that's going to be equal to a new sy over sx when I swap the original x and y variables from the regression. So now, before, remember that my x was money and my y was points, but now they've swapped. So that means that now my y is going to be money and my x is going to be points. So when I do this, I'm almost back to a slope. What I have to remember is that in order for me to take sy over sx and turn it into a slope, I have to multiply by r. Well, r in our problem was that 0.48. So I'm going to take this entire blue that I have, and I'm going to now multiply it by 0.48. So over here, I'm going to do the same thing, and I'm going to say 0.48. Now, when I do this, I'm going to say 1 divided by that very long answer of decimals, that 0.0130. I'm going to hit equal and then multiply that by 0.48. Now when I do this, what I get now is that B1, which is the slope, is equal to 36.864. But we have to be careful. This right here is basically currently talking about dollars. Now when we take a look at what the problem wanted, it wants the dollars to be expressed in thousands of dollars, not just dollars. So that means I need to take this dollar amount and divide it by 1,000. So when I do that, this is going to turn into let's see here, 0.36864 thousands of, or dollars per thousands of dollars per point. So when I look at that, that means that now I can say, oh, coming up here, A is the best option that I have.